So problem 11 says to design a non-inverting amplifier with a gain of 2. At the maximum output voltage of 10 volts, the current in the voltage divider is to be 10 microamps. So what that means is that we need to design this amplifier with a gain of 2 so that the input to the output relation is by a conversion of 2. And then there's an additional condition applied to here, says that whatever case that of input voltage causes the output to be 10 volts, whatever case that might be, the current in the voltage divider has to be 10 microamps. So 10 microamp have to flow through this voltage divider path here. So to start off, how do we solve this problem? First of all, let's recognize that there is a virtual short circuit assumption. That in the ideal op-amp, it is assumed that the input terminals are shorted, and we call that same voltage called Vx. So in which case Vx, or the non-inverting terminal, is connected to V minus. So we say that V minus is equal to V plus and is equal to Vx, or in this case is connected to Vn. So with that in mind, let's do some KCL. So first, let's recognize that in the ideal op-amp, we recognize there is no current that flows into the op-amp. So whatever current is flowing through here is the same as whatever current is flowing through R2. And you can define that current to be this voltage minus this voltage divided by that resistance. So it is 0 minus Vx, which is actually it's Vin divided by R1. Vn because there's a virtual short circuit across the input terminals. Now another way to define this current is to be this voltage minus this voltage divided by that resistance. So it is Vin minus Vout divided by R2. Now let's do some cross multiply across this equal sign. So negative R2 Vin is equal to R1 times Vin minus Vout. Let's distribute this R1 to the Vin and also this R1 to the Vout by multiplication. Then okay, at this point, let's move the let's move V out to the left side and V in to the right side. So R1 V out is equal to R1 V in plus R2 V in. Yeah. Okay, so we're solving for gain. So in which case, yeah. So actually, in which case, so the left side stays the same, R1 V out, but the right side is we distribute out this V in, and we have R1 plus R2. And then to solve for gain, so gain is equal to V out divided by V in, which is equal to, well, let's see here. So it's R1, R2 stays at the top, and then R1's at the bottom. Yeah. Okay, so one more thing to point out is that we had a condition that the gain needs to be equal to 2. So this is equal to 2 here. Now multiply out the denominator, so it's 2R1 is equal to R1 plus R2. Let's subtract the R1 on both sides, so we are left to R1 is equal to R2. So this is one of the conditions that we're going to save and come back to and revisit it in a little bit. Okay, there's another condition. It says that the current in the voltage divider, we need to make that 10 microamps when the output voltage is 10 volts. So whatever input causes the output to be 10 volts, in that exact case, this current path here has to be 10 microamps. How to do that? First of all, we need to figure out what input voltage causes the output to be 10 volts. Well, we know that the gain is equal to 2, which is just V out divided by V in. So it says that when output is 10 volts, the input is what voltage? So the answer is, well, 10 divided by 5 would equal 2. So V in is equal to 2 when V out equal to 10. Okay, so we're going to be solving the current through that voltage divider for the case of V in being 2 volts, which is synonymous with V out being 10 volts. Okay, so again, to repeat from before, no current enters the input terminals of op-amp, so this current is equal to this current. So we can categorize the current through the voltage divider to be this voltage minus this voltage divided by that resistance. So 0 minus Vx, Vn. Vx is same as Vn due to short circuit approximation, and then divided by R1. This current has to be 10 microamps. Micro is times 10 to the negative 6. Now, keep in mind that we are looking at the current path. So normally current flows from the high voltage to the low voltage, but because we're defining the current path in the reverse direction, going from 0 to a positive positive 5 volts, because we flipped the current direction, we have to put a negative sign in front of the current. Okay, so now we have V in divided by R1 equals to 10 microamps. In our case, we're solving for the case when V in is either equal to 2 volts, which is synonymous with V out being 10 volts. So negative, I didn't write down the equal sign. So negative 5 divided by R1 equals to negative 10 microamps. So just eliminate the equal sign, the negative sign. So what you're seeing is now our solve for R1 is equal to 5 divided by 10 to the microamps. Okay, so R1 is equal to 5 divided by 10 is 0.5. A division of micro is the same, so a division of times 10 to negative 6 is the same as a multiplication of times 10 to the 6. And we know that R1 is, so from this condition here, we know that R1 has to be equal to R2. So R1 is equal to R2, which is equal to 0.5 times 10 to the 6, which is mega ohms. And this is the final answer.